So I took it upon myself to do a little research into Lynn Margulis, being that she passed away in 2011, and I was a bit frustrated with that. What is life? This is written by Lynn Margulis and Dorian Sagan. I bet you can tell what happened there. Dorian Sagan is the son of Carl Sagan and Lynn Margulis. So they had a son together. I think that's fantastic. I'm going to kind of curb the cursing. One of my viewers requested that I curb it. But anyways, on page 126, I'm reading the hell out of this book. I'll read it off to you guys and explain something that it just stuck out to me. In many animals, the centrioles, the telephone, dial-like structures here. You know what? I'll just go ahead and present what this is first before there's any more confusion. Inside of a cell, you have what are called centrosomes and individual centrioles. Centrioles, I think that's how you pronounce it. But that's what they look like. And they're inside the cell, right there. They help with, separating the DNA when it undergoes mitosis. And a good way of memorizing how some cells separate, adult cells versus embryonic cells is mitosis is my toes, and meiosis is my ovaries, even though, I don't have ovaries. That's a good way of memorizing it. So a lot of cells that undergo mitosis use these centrioles, because what these magical little things do is that they branch out and they make big strings of fiber that branch out, and that's what helps separate the DNA. And sometimes those strings of fibers branch out at the edge of it and make a flagellum. I think it's called a flagellum, basically like a cellular tail. So like a cell will have like a little tail that can push it around. And I don't need to make a few examples for you guys to visualize what that probably looks like. But basically here, you have a non-flagellated centriole and a kinetosome. So basically, they're the same things, functionally, before they grow their things. So this is a kinetosome, which has, they call it that because it has the things coming out, the fibers coming out of it. And then this is the centriole, without the fibers. So they're the same things, basically. But in the past, they thought, biologists thought they were two separate things altogether. They thought they were individual structures inside the cell, but they were the same things. And so I'll go ahead and read this off to you. In many animals, the centrioles, the telephone dial-like structures, move to the edges of the cell, where they become kinetosomes by growing shafts. In cross-section, the shafts show a distinctive 9 pairs of 2 of them, plus 2 in the center. 9 sets of 2 tubulas arranged near the perimeter of the circular axis. So you have 2, 4, 6, 8, 9 on the outside, and then 2 in the center. The kinetosome and centriole have different names only to distinguish the shafts from the shaftless phase of the same organelle. Multiple names for the same organelle are more accidents of history than nomenclatural necessities. 2 names were bestowed because the distinct phases were noticed and named long before any relationship between them was recognized. Does that sound familiar, you guys? 2 individual names for the same thing in different phases were given, for the same thing before the connection was realized, before the pattern was found. That's exactly what's happening here. The planets are the ancient stars. So the pattern for astronomers, they say, well, these are individual constructs and these are individual constructs, yet they're the same things. They're just in different phases of their evolution. Similar to biology. How many times has this probably happened in biology where they found the same object, yet they think it's 2 separate ones because they look different? But no, it isn't true at all. They're the same thing. Just one is in a different phase and it's doing different things at a given time. And, well, as weird as it may sound, I mean, doesn't that look like rays of sunlight coming out, and then there's no more sun, there's no light, no more light coming out of this one? But yet they're the same things. So I don't know what to make of that, really. I just thought I'd out there with science, and I didn't learn this in my biology, or my physics classes, or my chemistry classes. That can happen, where people, they make a discovery of something, and then they make a discovery of something over here, and they give two separate names for them, yet they're the same thing. I think recently what happened, I don't want to say recently, I think about 4 or 5 years ago, maybe 3 years ago, maybe even a decade ago, I'm not too sure, I have to look it up, because things in science take a long time to change. There was a paleontologist who discovered a baby stegosaurus, I believe, and for the longest time, paleontologists were saying it was a separate species of dinosaur because the way the jaw was located, the way the bones in the skull were formed, the way the body was shaped. They said, well, this is a distinct species. And this one paleontologist was like, no, it's just a baby stegosaurus. It's not its own species altogether. So he took so many years for them to point out that it was the same thing. It's just a baby version of an adult stegosaurus. I'm saying stegosaurus because I think that's what it is. I'm not too sure. It might have been a different type of dinosaur. But it was the same damn thing. And that is a big problem in science, is because what happens is these scientists, they get so used to using specific terms to define something, and they get set in their ways. It becomes a socially accepted term. Everybody has a shared definition of that term. And if you run around, for instance, say you're running around, in your neighborhood and you see a dog, you don't, point at it and say cat as the cat right there. People are just going to look at you funny, like, what the hell are you talking about? But, yeah, it's very easy for scientists to get used to calling things a certain way, and then they form worldviews around the way they call those things, yet their words they use are what are getting in the way of them understanding what it is they're actually looking at. And I don't know, there's probably more examples of that, but probably a whole hell of a lot of examples in this book. Alright guys, I won't keep this too much longer. Take it easy.